T2 demos. T2 demos. T2 demos. This is the first test to try to do time-lapse with the X-T4. There's the parameters. We're going 300 times. Speed up, these are JPEG frames. There's lots of problems with this, but it's fairly encouraging. I'm worried, since this is just one power zone, I'm worried about when we get to like 9 power zones, whether there's going to be enough res. But we'll see in the second demo where I do some camera projector automation, I'm calling it, that it looks pretty good. We can push from here, we can push all the way into a single tile after the fact and still like read the text, for example, which was not really true with the previous solutions. I don't know if that will still be true with 9 power zones, but we'll see. So this was a big update of almost everything, because I hadn't had this grid fired up for quite some time. I'd been working on the single ring, and then obviously just doing a Hugene run, which I wanted to run until it settled one way or the other all by itself, but I didn't really understand how the Fuji X-T4 works, and its battery died. So that's where this simulation ends. All right, so here we are pushed into a single video, also with a little bit of color grading, since the background of the CDM menus really should be brown. And the LCDs we're using are really so low quality. So I've just tried to get this to approximate, to sort of emphasize rendering what passes for true colors on the LCDs, and let the the T2 tile cases and the surrounding environment and stuff go hang. But I'm also and this is using the Kdenlive transform effect with keyframes that are set to smooth, which is cubic splines, I think, and I'm starting to get them working. You can see that this is actually fairly smooth, and it doesn't have a lot of changing in directions that don't make a certain amount of sense given the action on the screen. So this is it. This is the first test. I've now got an order for one of these dummy battery things that connects to a charger so that it's not relying on USB power. So hopefully we'll be able to do much longer. Lots more stuff to do. Just figured I'd put the first test up. That's it. Hopefully the volume levels are a little better today. Don't get the ducking where the background music theoretically gets quieter when I'm talking. Hopefully that's been adjusted a little better. We shall see. Hey folks, welcome to the Artificial Life Advanced class. So where we've been running these growing diamonds on the T2 tile grid since August, and the first time we did it, a couple of weeks it ran, and then it ran into a internal error of some kind which caused a crash storm and took everything out. There was not an absolutely clear diagnosis as to what it was. My suspicion was that in very rare cases it's possible to run out of space in what I had allocated for packets to get exchanged back and forth between tiles. I increased the size of that by a factor of 4, distributed it all out to the grid, and started the whole thing up again. Put a couple of dozen seeds, growing diamond seeds on the grid, same code, and let it go. And so how has it gone since then? Well, let's take a look. I made it into a game. I mean, the algorithm, what happens with these growing diamonds is if there's enough of them, they grow until they fill space and they jam up, and then eventually one of them decides to check out, and that creates more space, so they grow again, they lock up again. And the game is, can you do better than chance at figuring out which of these diamonds is gonna die when they jam up? I didn't get that one. It's not always, the answer is not always B. I have a theory here. Yeah, I thought it was going to be B this time. And all right, so now it's jammed up. What do you think? Yeah, it's B again. I just labeled them from left to right, top to bottom, you know, when they pick some that are jammed up. All right, so here, this is where I put in some more seeds because it was actually getting too loose. Now it's jammed up again. I think I know this one. What do you think? Yeah, I know that one. And so that makes more space, and then they can all jiggle around again, and they lock up again. All right, one more. It was B again. It's just the way it worked out. But the bigger picture is that, well, so first point is, how can we possibly predict? It's supposed to be random, and it is random at some degree. Now, the idea is, the way these diamonds work is that decisions about whole diamond level stuff like motion and growth happen at the center of the diamond, and that control code is designed that wants to see them move, and when it sees the center move, it resets this timer that keeps everything going. And when things jam up, the timer does not get reset, and eventually the timer's got some randomness in it. Eventually one of them reaches its I give up, and it kills the diamond, and that creates more space. But again, there's no actual wall clock timer that's being provided to these things. These individual sites on the individual tiles, they don't know any kind of absolute time. That would be unscalable, exactly the same as if they knew their exact coordinates in space. They don't know either of those things. All they know is when they get an event. And an event is random. Events are asynchronous, but that doesn't mean that every site gets the same number of events. And in particular, when an event happens toward the edge of a tile, an intertile event, those take longer because of the communication and coordination necessary between the tiles. Whereas an event that happens all in the middle of a tile that requires no communication starts and finishes much quicker. So you get many more events happening in the middle of the tiles than you do at the edges. And as a result, in effect, time runs faster in the middle of the tile. So if you look at these, so this one, you know, the middle of the tile is right about here, and the middle of the diamond is somewhere around here. It's not exact center, but it's fairly well centered. This one, same thing. It's the center of the diamond is not too close to the edge. This was in the lower left. This is the one that I shore. You know, the diamond, you know, right in the meat of the. Well, actually, that one's even a little close too. So time runs at different speeds at different places on the grid. That's really weird. That's like science fiction stuff, but that's what we signed up for when we are going for indefinite scalability. And how is it actually going to end? The big picture? Hopefully it'll end because I end it, because we have code to run that we want to do instead. At the moment, we're just continuing to stress test with the growing diamond. So we shall see. All right, we are at T-5 on the artificial creation countdown. And, you know, that means, you know, we are at the halfway mark, and we've got 5 updates before us, 5 updates after us. We're not quite at the halfway mark in terms of days, because we have this big chunk of time in November where we do not have updates scheduled, but we're increasingly far behind. We were supposed to have the HC3 sequencer in August. We didn't. We're supposed to have state machines in September. We don't really. So, you know, last time I talked about the T2 tile water report, and I had lots of detailed stuff. But afterwards, thinking about it, what I generalized was, yeah, whatever. I don't really care about those. The main thing I care about is public embarrassment. And then if I'm caring about that, why am I doing these, YouTube videos, live streams, and so forth? Well, of course, because that's the way to keep myself focused and to actually try to make progress and not just say, oh, yeah, I'll do it next year. But once I got as far as thinking, well, what I'm really afraid of is the nightmare and the going to school in my pajamas, then the response to that was, well, yeah, I might make a fool out of myself or screw up the audio settings and so forth, which I still can't do very well. But I'm still convinced that the underlying ideas, indefinite scalability, robust first, best effort, those are good ideas. Those are ideas that are underserved in our current technological, digital computing, information technology environment, and we need to get them out there. So that just leads me to the fundamental feeling that, well, okay, I can be an embarrassment, I can moan and groan, and people kind of go, ew, just back away slowly. But my job is just do the work and put it out there, and then we'll see what happens from there. So that is the title card for this time. We don't have a specific technology to go after, so we're just saying it's the halfway point of the countdown between T-10 and T-0. And for me, the takeaway is just do the work. Okay, so for this time, we were supposed to have a self-copying program demo. Ha! Didn't get close. A loop reshaping demo didn't get, but I sort of got something that's related to it. Have some fun. Well, it was a little bit challenging, the last kind of updates, because there was a lot of frustrating stuff. So we shall see. What I want to spend a couple of minutes on here, I'm determined not to go long, is to talk about spatial programming in one dimension. Well, wait, the T2 tile is 2 dimensions, and everybody complains, why isn't it 3 dimensions? But in fact, it's nested structures at all different scales. And when we're talking about programming, which is what I've been focusing on exclusively, we're using these pocket chain loops, which are laid out in 2 dimensions, but they are logically 1 dimension. There's next and previous and next down the loop, and it really doesn't care where it is. And what that led me to the realization was that, for a long time I was against abstraction, and, because abstracting away space, as we did with CPU and RAM, random access memory abstracts away space. Location 100 and location 1 billion are equivalent. You can put anything in one, you can put anything in the other. But the guilty party is not the abstraction. The guilty party is discarding space wholesale. What we want to do is do space preserving abstraction, maps, and increase scale slowly. And as we increase the scale, we have more stuff that we do not want to deal with ourselves, so we want to delegate the spatial details. And whether the lower level deals with it by performing searches, or it caches to remember what it needs to do, whatever, that's not our problem. As we climb up the levels of larger and larger scale to become more and more abstract, which we still do want. So we've already got, we've got a lot of levels of abstraction already. In the movable piece machine, from individual sites, where we have tiles full of individual sites, to the idea of the HC3 diamond with individual pockets, and we in fact search through the pocket to find the contents there each time we need to do it. Is that less efficient than knowing the exact one? Yes, but it's more flexible, it's more abstract. And now we're taking it to the next level of actually, creating languages for describing what happens along the 1D chain, where now we're ignoring the pocket structure. It's all just next and pre. We don't care whether it's up, down, left, or right, and the sites are gone. And so what I don't have a real language for it, but I've started to work on a little bit of notation. We've got a few basic ideas. X is a content carrier on the pocket chain. Y is another pocket chain kind of carrier, and X is specifically one of the things that we have to be careful of. That's going to be an instruction in the program. The Y is going to be either an instruction or just a temp like that. We don't care. And EC is an empty codon. So we can make rules that we say, if you've got an important one and one that might be a temp, or an important one followed by empty codon, you can swap the important one with the empty codon. And the important point there is that the empty codons don't affect the ordering. As long as we don't swap any X's with X's or X's with Y's, we will keep the underlying ordering of the program. We'll just have more or less empty stuff stuck in there to fluff up the loop, because we want the loop to be fluffy but not floppy. Fluffy means that we have, empty space in between so we can move things around to get them forward and get them backward where we need to do. But floppy means we have tons and tons of empty stuff, which means when we need to drive something that counts all the way around the loop, it's going to be very efficient. And so I've implemented a bunch of these rules, in code. So there it is. Pattern Y, pattern X, pattern empty codon, and so forth, and pretty much directly reflect the rules. So that's the kind of design that I've been working on in the last couple of weeks, and that's the reason why, we're busy making the program chain, the one-dimensional representation that's going to hold the program. We're making that more able to take care of itself. Okay, and we have a couple of minutes. Maybe we could take. All right. So here we've got a diamond that we've already started. I have gone in with a scalpel and removed the. So I've got a thing called insert here. All right, so here's an insert Zong atom, and if I give it an event, there. Okay, what did that do? That just looked around to find an empty codon, that's the EC, and converted into a Zong, which is just a debugging type that I've developed. And, all right, so now we can let this thing run. I suppose I should change the, go to the, all right. So now what we've got is we've got two loops, each of which consists of, well, so we can't really tell it, one empty and one Zong. And what's going to happen if we let this thing run for a while, which I don't know if we can really afford to take the time, unfortunately. These things will eventually, they will grow out, because they'll use those rules where they've discovered that, there is not enough, we're kind of crowded, so we've got a Zong and an empty, and we'd like to have a little more empty, so it'll go ahead, I hope. Maybe I'll leave this running and we'll come back to see if it's actually managed to spring any of them things. Well, actually, I guess we could look at a little bit. I've got a clip. All right, this is a one that I set up ahead of time that we can just look at, and so here we've got it's already growing out to a bunch of slightly bigger stuff, and eventually this is going to pick up speed and go faster. All right, there we go. And so then we can kind of see it, that these the for loops are not filling the entire diamond. They're not even filling their own quadrant anymore, because now they're only getting as big as they need to be fluffy but not floppy, given how much actual content there is in there. And each one of those loops has 3 Zongs in it, so it grows out to about double, 2 or 3 times. It's local, it's random, so they get a little bit floppy, but I don't feel too bad about this. All right, so that is that. For next time, the goal is to have actual programs that are living inside this to take care of itself thing. Spike assembler and loader, we shall see. And please have some fun. Yes, folks, thanks for coming and taking a look. We're at the halfway point. We shall see how it goes. I hope to see you next time. All right, so I'm going to stop the recording here. Okay, so once again, if I don't know if anybody's in the live stream or not, but I feel like I was kind of getting a little sappy last time. So if nobody's around, I'm not going to feel committed to waste time until the top of the hour unless something comes up to talk about. We'll end it whenever it seems reasonable to end it. But I'm going to take a break now, so we'll go back to the waiting room in order to get the render started so that we can get the episode up. All right. And folks, thanks so much for checking out the live stream. T2 demos. T2 demos. T2 demos. Hey folks, okay, the render is going for what it's worth, and once again, because I still haven't figured out what to do about the fans on my Dell workstation, they're going to be cutting in and out with some regularity. So, why don't we check back in on the, okay. Now, is that working? Oh yeah, I guess it is. That's just tiny. All right. Yeah. Okay. So the Grow Diamond has done what it does, but look, these guys haven't decided to grow. I don't know if that's a bug or I'm running a weird version of the code. Why don't we go ahead and try to seed another loop here, someplace out of the way, hopefully. Oops, once again, the interface that I can never remember after however many years of using it. All right, I'm just gonna, all right, there we go. So we'll plop a seed loop right there. We will let it, okay, so it sprouted out. All right, we'll let this thing grow up to like 4. Maybe the problem was I think the problem actually was that I missed with these things. All right, so now this thing is growing. We'll let it go one step bigger, I suppose. Let's let it go to 6. I hadn't even really figured out before that loops are always an even number of segments. Because they start out as 2, because the code really doesn't support connecting to yourself, so they start out as 2 connecting to each other, and the grow operation adds 2 more, so they're always even. All right, so let's try to use the delete codon to get rid of this demo. I don't think that worked. Let's try again. See, it's really better if when we're doing this, if we use the regular display. Yeah, here we go. And don't use the, okay. So now it's easier to see that that's a demo, easier to see that we're using a delete code on here. I'm not sure why that's not taking. All right, there it is. It took a little bit of extra doing. All right, so we get rid of that. And now, so now the goal is to create some zongs that will take up space and thereby trigger the background logic to grow bigger. It's currently 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And can we put make some zongs here? Maybe here and here. Let's see if we can get those to work. So now I'm using the magic of the spark where I can deliver events specifically wherever I want them. And I'm not sure why that, again, the grid is bent. That's this when the grid is bent, nothing can really happen. So we're actually going to have to wait for the movement to fly through here. All right, and there we go. All right, so now we've got 1, 2, 3 zongs. Let's get rid of this and put another one over here. That looks actually, oops, that's already a zong. How about this guy? This bean. There we go. Okay, so now we've got 1, 2, 3, 4 zongs in the loop, and I believe if we let this cook for a while, that will grow a bit larger, but it will not grow so large that it actually wipes out the whole, fills up the whole quadrant, let alone the whole tile. Now I guess we can go back to the minimal display. Okay. All right. And so we got 6 zongs total in the universe, 4 in the loop we just made, and 1 each in these ones that failed to thrive because I should have let it grow to 4 before starting it up. And the empty codons are 10 total. We'll see. Anyway, so that's what's happening on that front. We'll come back and look at that if there's any. Oh, hey. I didn't see the folks that had checked in. Thank you so much for coming and taking a look. Any progress is good progress. Thank you. Thank you, Phoenix 1328. Lou in the Discord was talking about how it's fun to have the ticking clock, to have the countdown, even if I don't actually succeed. And, I guess that's true, but, I feel like I have to care. I have to take it seriously enough to think that I need to finish this. Otherwise, I'm terrible. If I know that a deadline is really just completely internal to me, then, I'm a slacker. But if it's actually an external deadline that I'm committed to other people about, well, then that's a different story. So, even if, yes, I know the world won't end, I just made up this deadline for the countdown for 2023, January 3rd. I think it's January 3rd. I keep saying that. I haven't checked it, or I haven't checked it lately. I know it's all just for me, but, folks watch the videos, 100, 150 people. Last time, T-6, didn't do very well. Uh, um, because I think the title of a serial computer, whatever it was, engineering a new serial computer, like who the hell cares about that? I wanted to have something really lifey, because the ones that have done well is engineering digital DNA. I mean, comparatively well, in my little competition of top 10 against myself, engineering digital DNA, engineering digital death, they were way up there. Building a new serial computer, hell. But there's also this pattern that the ones that get fewer views, they get more watch time. People watch a bigger percentage of them, which I interpret as it's actually only people that really care, people that are actually interested in this stuff, actual living computation nerds. Are watching this stuff, and then come on, that's a pretty damn elite group. Anyway, so why don't we go back and take another look at our. All right, well, now we're up to 12 empty codons. We were at 10 before, so somewhere along the way we actually managed to grow. I don't. Is this? Not sure if this is logging anything. Oops. Okay, it looks like it's only actually logging where cell growth events, which are really rare. It's a funny thing, in a simulator or a debugger, you think, hey, logging, that should be cheap, that should be free, and it's reasonable in the MFMS simulator, except when you have lots of tiles being simulated, those are each happening in a separate thread of execution. But the log file is merged, all the messages from all the different ones. So in fact, the simple act of logging a message requires getting a lock, a global lock over the entire simulator. So, shapeshifter. That means it's going to be growing again, wherever it is over here. If it works successfully, although it may or may not. But we've got a couple of shapeshifters actually out there now, so something will succeed pretty soon. Let's see if we can catch. Here's this dark blue is a shapeshifter there. Oh, and in fact, it just did it. It just put on a new wing on this loop, and so good for you. And anyway, this is in this weird situation. I'm still screwing around with OBS. Their new version 28 that just came out, it has been a little bit challenging. A bunch of stuff sort of stopped working now. There was just an update, the second hot fix or whatever it is, that perhaps unwisely I installed, like 3 hours ago. But it seems like it may have actually fixed some of the bugs that I was seeing in the previous version. So I guess I'm glad I did it. And step by step. All right. Well, so I don't know that I have a whole lot more going on, except sitting around and staring at the simulator. So I don't know if we should. How are we doing? We're still at 14. Now, I guess there's one more thing that we could do. Actually, I suppose we could do it. I could just create a regular loop using demo with get another seed loop here, and because I think the demo grows quite a bit faster than the self-regulating stuff. So because demo the red fat guy, has, you know, something like if it has an empty spot next to it, it has something like a 1 in 15 chance of popping out a shapeshifter, which, like right there, can cause the thing to grow quite rapidly. So there's the shapeshifter putting out the corner and the side just has to hook it up, and then boom. And so then off we go. And so one of the things I was going to show you, since we have a little bit of time, what the heck, there goes another shapeshifter, corner, side, boom. And that's the way it works. You know, you're taking one segment and replacing it with 3 segments whenever you can find room to do so. Now we look at that. So we got we had 2 shapeshifters. So demo is quite profligate. Is that gonna? Yes, it is. So this thing is putting out plenty of growth. Now, the seed loop is designed so that when it first creates a new loop, it looks to see what quadrant it thinks it's in, which in this case is 0 is northwest, 1 is northeast, and 2 is southeast. So if we take a look at this, just to check my memory here, if we take a look at some of these guys, they are in target quadrant 2, yes, and then southwest is target quadrant 3, and that gets passed along to everybody. And even if you're in the southeast quadrant, you're actually able to go a little bit over the equator. So there is sort of a zone of contention near the axes of the, but mostly they stay in their own area. So this is going to fill up the southeast quadrant pretty quick. And then what I was going to do is I was going to show you one of the other things that I developed in this last update period, which is going to eventually become an instruction in the loop operations instruction set of this sequential computer, this sequencer. But it isn't there yet. And that's the reason why I have a little bit of hope that the goal for the next update of actually having data diamond sequencer programs, plural, is not completely crazy. We'll find out. I would say hope springs eternal, but except when it doesn't. All right, so why don't we say this thing is big enough here, and one of the things that we certainly want to do when we are a piece of code is we want to be able to initialize other loops so that we can fill them up with stuff, and we would like to be able to make loops for temporary purposes and use it as a stack and then pull stuff out and then be done with it. And we'd like to be able to get rid of loops when we're done with them, and so that's what Loop Killer does. So let's make one of those and watch what it does here. Again, let's turn this thing off because it's just easier. I am going to put it, where am I going to put it? I'm going to put it at this corner down here. And the idea of the Loop Killer, all right, I think that is that? Right, that's in the neighboring square to this corner. So there's a good chance, depending on which way the events get distributed, that this thing will trigger a loop killer in the, well, actually, let's try to give it a little head start because we're God and we're mean. All right, boom, yeah, there it is. And so, right, that's a loop killer. And it blinks. When it gets events, it blinks back and forth from black and white, just to try to be different than everything else. So now we can watch it go. And so it's heading downstream, chasing around. But whenever it gets to a shapeshifter, like there, It has to wait until the shapeshifter is finished doing whatever it is, and there we are. Okay, the loop killer did its job. And that's the second version of the loop killer. The first one, the first one was more efficient. That when you seeded a loop killer on a loop, there's two directions on a loop, so it would send the loop killers in both directions, and when they met at the far end, then the loop was killed. And that was tricky. It was kind of fun to watch. But this one that just sends the loop killing in one direction is actually better. And why? Why is it better? It's better because the loop killer that you place there stays there until the job is done. And as a result, whatever process plopped down that loop killer to begin with can just sit there, and as long as there's a loop killer there, they know it's still in progress. Otherwise, if the thing just ends hell and gone over the diamond somewhere else, how does the program that released that loop killer because it wants to do something else know that the loop killing job is finished? So having it start and end at the same place, even though it could be parallel processing, means that once again we get the stigmergic signal. As long as there's a loop killer there, we have reason to believe that the loop killing is still in progress, and it may take widely varying amount of time depending on how many shapeshifters and other things there are. It has to wait for them to locally finish up. It's actually kind of fun to watch the thing go. I mean, it seems a little silly that if you kill a big loop, like the sort of thing that the demos will do if you give them their enough time. Although we can see over here that even the new stuff, just using its own internal logic, continues. We're up to 16 empty codons there. When you kill a big loop, like the kind of things that are running on the grid now, using a loop killer, it's sort of strange because, it's freeing up a ton of space, and some of the shapeshifters, which had been patrolling around and not finding anything to do, end up saying, oh, hey, there's open space. And they go ahead and they start growing into the open space that the loop killer just killed as it was heading down before coming back up or whatever it is. And the loop killer dutifully waits for the shapeshifter to finish constructing a new wing on this part of the loop, and then immediately mows it down like that. And again, I used to think of that as being silly and inefficient. Why build this thing if you're just going to lose it anyway? And the response to it is, yes, but it's so low order and local and sensible. And if you try to get every little ounce of efficiency out of things, then you're going to become fragile. And to just say the shapeshifter, given that it exists, then that is its license to go around and try to find a place that it can put on one new edition, and then it erases itself. And so if you need more new editions, then you need some process to generate more shapeshifters and leave them patrolling around. And that's what demo just does spontaneously. If it sees a shapeshifter ahead of it, it doesn't create another one. And if a shapeshifter comes all the way up around the back and sees a demo, it just wipes itself out, figuring, okay, I did my full patrol, never found anything to go, so I'm going to just wipe myself out and let the demo being, generate a new one. And so this guy's doing fairly well. I don't have a insert element that would allow me to insert a demo back into one of these things, but whatever. So, what's going on? Oh, hey, I haven't seen David Kiersey for a while. And EM13 Electronic Music. Hi. Thanks for coming. Always with the well, that's what makes it fun, right? That's why I do it. I tell myself that it's for the good of society, and I actually believe that. But on the other hand, I'm so far out in space. I'm violating so many of the assumptions that are, bread and butter to information technology. Just because I got tired of all the standard assumptions and trying to come up with something new, trying to come up with something, a fresh intellectual concoction, is what, what keeps me going like that. I still, just like the mission in life, my mission in life, make something, do something by itself. And the Movable Feast Machine, the T2 Tile Project, and now the A Life Creation Countdown are all takes on making something, do something by itself. Thank you, EM13. So, David, Kiersey, send an email. We could try to find a Zoom slot. What the heck? You've been part of the T2 Tile project since pretty much the beginning. So if you want to chat, let's chat. No expectations, no nothing. All right. So I don't know if I have anything else really pressing to present. I don't. Never stopped me before. If people want to hang around, we'll talk. Why don't I start a few more of the old demo loops? If we could just get a big guy, of course, a big loop that we can then wipe out. I'm always afraid of doing this while the grid is moving, because then I might end up wiping out one of the HC3 diamond axis pillars itself. And there is recovery code there, but if and the recovery code works okay if the grid is static at the time the thing gets punched out. But if the grid is in the process of moving, if the grid is deflected, is distorted when one of these things gets turned out, that's when there's still possibilities of getting deadlocked. And then it's just a matter of waiting for the root watchdog to go, what the hell's going on? And in fact, I didn't point it out, but in the run that we currently saw, where we had the pop quiz for guessing the death games, the crowding games, in the upper left-hand corner, there's a little diamond up there that you can see, if you know to look for it, that is not moving even when it isn't crowded in, because, in fact, it's deadlocked. And it also is, so I keep waiting for it to just decide to punch out because of the root watchdog. But also, I think this is true. Actually, I'm not 100% positive this is true. The center of that deadlocked diamond might be quite close to the edge of a tile, so in fact it's getting events relatively slowly, so it's going to be there a long time relative to the rate that time is passing in the middle of the tiles elsewhere on the T2 tile grid. So there's all of that happening, and once upon a time, when I was coming from the top-down, fix the last bug, if you have any self-respect as a programmer, you'll handle all the corner cases, you'll handle all the edge cases. And now look at this. I'm increasing the size of buffers just to hopefully make a bug go away. That is one of the lamest things that happens in networking hardware and software. Traditionally, people that are serious about networking and distributed system stuff mock the people that just increase the buffer size when there's a problem. And yet that's exactly what I did. Now, we'll see whether I come back and get bitten by it. I mean, there still can be multiple reasons. There always can be a hardware error, a cosmic ray, some kind of glitch that causes a packet error to fail checksums or to get dropped for one reason or another. Now, a bunch of that stuff does log, but it just logs onto the Linux running on that one tile where the event happened, and actually exfiltrating those log files is decidedly non-trivial, especially given that the Linux boxes only have a couple of dozens of of megabytes disk free at any given time, so the logs are actually rotating fairly, fairly fast. So if you don't get them in a reasonable amount of time, you're not going to get them. So, from the point of view of when I used to teach, design of large programs classes at UNM, I am a shameful, terrible student at the moment, because I am not, making sure it's right before I hand it in. What, you ran out of time? Oh, well, then why didn't you start early? Every freaking T2sday, I run out of time. So, of course, and then I just tell you, the dog ate my plans, and that's why I have this tiny little irregularly shaped pebble that I picked up on the way to school to show for show and tell. I'm seeing the Matt Groening life and health stuff is going by my Twitter these days. Haven't seen them in a few decades. So it's the same thing, but now we are no longer in the land of top-down crystalline, you control the horizontal, you control the vertical. We are in the land of stuff at the bottom may go wrong, and that's a big drag. But the flip side of it is that as long as it's reasonably rare, you can as long as it's reasonably rare, number one, you can kind of live with it, and number two, as long as you have some kind of backup, as long as you can recover in some cases, or as long as, for example, your cell program reproduces itself. So if one copy of the cell happens to get into a deadlock and eventually takes itself out on the watchdog timer, the program still goes on because it's been copied into other cells. So the artificial life creation countdown that we're doing right now, it is a fundamentally, if nothing else, it's a robustness enhancing feature because it gives us redundancy at the level of whole cells, because each one of them is going to copy this little chain that represents the program that's going on. It remains to be seen how much complexity we can fit into the program, and we're going to take a bunch of the complexity to just deal with copying the program and reproducing the cells and sequencing the steps of reproducing. But in theory, you could then have more stuff that isn't related to directly to the copying and the splitting and all of the stuff that the reproduction process needs, but it will get carried along as well. And that's where we could put stuff to, I don't know, generate little neural nets and start sending packets to each other and so on and so forth. That is not going to happen by January 3rd, 2023. I do have in mind one more project. If I actually manage to survive this, and we'll see. Some days are better than others. But there is one more push after this to grow out more lotuses, make the grid bigger, and run so that we can get more of these diamonds running simultaneously and get these diamonds starting to talk to each other, to interact with each other, to do a larger scale control of some kind of simple system. And at that point, then I would say, okay, well, screw it. I've done my job to try to make these ideas as believable as plausible. And again, I'm doing it in the bottom-up style, where instead of presenting you with facts about the world, I present you with demos. I present you with capabilities. You could build a thing that would run like this. If nothing else, you could check out the T212 demo directory, the repos. You can check out MFM. You can check out Ulam and Splat. You can build them. You can run it all on the simulator. And then you can modify it, and you can take it from there. And that is the heart and soul of bottom-up engineering, of building bottom-up, is that you show a sequence of demos that really exist, that someone in principle and hopefully in practice, and things like GitHub and open source and all this stuff. I mean, just like we're seeing with Stable Diffusion and all these things that, they cost $1 million or something like that. Well, there's plenty of rich people around who are willing to say, yeah, I'll spend $1 million once so that everybody can play with, text to image and so on and so forth. it's kind of amazing. People that are focused on the AI risk and everything, and the artificial general intelligence and all that. Yeah. Uh, um, there is more than zero risk there. But it seems to me there's a much more risk in plenty of other things that we're doing all damn day long, and nobody says, oh, we have to deal with it now. We have to throw millions of dollars at making rich people less jerky. Because, hey, wait a minute, they're not interested in funding that work. Anyway, I'm rambling. Okay, we're almost out of time. And so I guess unless anybody's got any thoughts, maybe I'm just going to try to, shut myself up here a little bit. And oh, the render is done. Okay. I should get that uploading. And so why don't I stop it here? Unless there's any final thoughts from folks. I mean, actually, I guess I guess I'll try uploading it while I'm streaming. Well, we'll find out. My connectivity is not that great. I don't even dare do it. I will wait until the top of the hour, and then I'll start uploading it. I think I managed to keep inside 15 minutes. It seems that YouTube has a certain, opinionated attitudes about how fast it actually converts and does all of its sniffing over uploads and so forth before deciding that they're ready to release. And it does seem significantly that shorter ones get more than preferential. I mean, obviously, shorter ones are going to take shorter to process once they've started, but it also seems that shorter ones are, quicker in line to get processed than ones that are like 25 minutes and stuff like that, where I've seen them waiting. And again, this may be finding patterns in noise. It may just be how busy the YouTube servers happen to be at any given hour. But I'm usually uploading on Tuesdays at around the same time, and I see quite a bit of variability. So, all right. Well, hey, folks, thank you so much for coming to the live stream. It warms my heart. Makes it feel like it's worth doing. And I'm still gonna, try to make the relatively short updates so that we can perhaps reach a broader spectrum of nerds, and how to actually go the next 3 levels to reach everybody with the sexy haiku of best effort computing. Remains to be seen. Well, I mean, I guess my Twitter feed is one more step in that direction, and that's getting traction. I seem to be stuck at just under 900 subscribers, and I seem to be pissing people off about the same rate that I'm drawing them in. So we'll see how that's doing. But hey, it's fine, and I feel like I'm getting more used to reacting in public, making comments in public. And every so often, if I happen to come across something that triggers a thought, I can make something that's a little bit funny, or at least, I think it's funny. So I go ahead and tweet it, and, sometimes people like it, sometimes they don't. Whatever. Okay, I am going to stop at the top of the hour. And again, folks, thank you so much for coming to the live stream. Or if you're just checking the live stream, if you're choosing to check the live stream out later, I love you too. It's 1:00 in Mountain Time, and so we're going to end for this time. Hope to see you live in 2 weeks.